ఎవడు ఎల్లయ్య అటు వెళ్ళిపోయింది ఎవరు చూసినా గేట్కి వెళ్ళి అంటే వేరే ఏమైనా పని చెప్పినట్టుంది మేడం అటు వెళ్ళినట్టుంది కీ తీసుకొచ్చారా కాదు లోపల కీ తీసుకొచ్చారా ఇది సెక్యూరిటీ కాడికి పోయింది సరే ఎల్లయ్య అటే పోయింది సెక్యూరిటీ దగ్గరికి పోయింది నేను వెళ్ళాను ఎందుకు ఎందుకు బాగాలేదని డ్రెస్ తీసుకో మేమందరం ఉన్నాం పోరి మేడం వస్తే చెప్తాం పో హెల్త్ బాగాలేదు నేను చెప్తాగా నీకు హెల్త్ బాగాలేదు కళ్ళు తిరిగి హెల్త్ బాగాలేదు కూర్చోవద్దు వెళ్ళిపోవాలి ఇల్లు ఉన్నట్టు నీటుకుందా నేను ఒక ఆయన కారు చూసిన ఒక అట్టపెట్టు మొత్తం ఒక 4-5 అట్టపెట్లు ఉంటాయి కారులో ఒక దాంట్లో డ్రెస్సులు ఒక దాంట్లో పర్ఫ్యూమ్స్ ఒక దాంట్లో స్నాక్స్ తినడానికి ఏ టైం తినడానికి అడాప్ట్ అయ్యాడు ఒక దాంట్లో బుక్స్ ఇక ఎటు ఇంటికి పోయినా పర్లేదు అంటాడు దేశం మొత్తం ఎందుకన్నా అంటే సాటర్డే నాకు మూడ్ వస్తుంది బండి వేసుకుని లాంగ్ డ్రైవ్ వెళ్ళిపోతుంటే ఒకసారి కర్ణాటక పోయినట్టు ఒకసారి కేరళ పోయినట్టు అట్లే అట్లా
Good evening, students. Our today topic is black 3. Today topic is black 3. Unit 11. Black 3 unit 11. That is 5-membered heterocyclic compound containing 2 heteroatoms. 5-membered heterocyclic compound containing 2 heteroatoms is the topic. Five-membered heterocyclic compound containing 2 heteroatoms is today our topic. So first, 5-membered heterocyclic compounds. We know that first we are going to discuss isoxazole. First we are going to discuss isoxazole. The structure of isoxazole is this is isoxazole. This is a 5-membered heterocyclic compound containing 2 heteroatoms. 5-membered heterocyclic with 2 heteroatoms is isoxazole. The synthesis of isoxazole. First, we are going to discuss synthesis of isoxazole. And synthesis from 1,3 diketones. 1,3 diketones and hydrogen hydrate. Hydroxylamine. Amide. So reacting with 1,3 diketones and hydroxylamine. So 1,3 diketones and hydroxylamines. So this is a 1,3 diketone compound I am taking here. This is a 1,3 diketone reacting with hydroxylamine. Here, first it is in presence of acid medium. It is involves loss of water molecule. Then forms oximes of carbonyl compounds. These oximes of carbonyl compounds here, that lone pair of an oxygen atom, they donated to carbonyl carbon, and that pi bond is shifting to oxygen side. Then here N, here the O, here OH, here hydrogen shifting to oxygen side. This involves loss of water molecule. Then forms isoxazole is the product. This is one of the best example for synthesis of isoxazole from 1,3 diketones and hydroxyl amides. Second one is from alpha beta unsaturated carbonyl compounds and hydroxylamine. Second one is from alpha beta unsaturated carbonyl compounds and hydroxylamine. Here I am taking, this is one of the example of alpha beta unsaturated carbonyl compound, and here, and this is the alpha beta unsaturated carbonyl compound, and when reacting with hydroxylamine, so here nucleophile attack at the beta position of alpha beta unsaturated carbonyl compound. This is a Michael addition reaction. Then this Michael addition, phenyl, here O double C, COET. Then it is OET, NH, OH. When it is undergo cyclization, so this lone pair of electron oxygen attack at carbonyl carbon, then forms a cyclic ring. OH, that hydrogen shifting here, OH, and phenyl, COOET, then OET, NH. So it is involves loss of water molecule. Here hydrogen is it. This involves loss of water molecule, and here involves loss of ethanol. Loss of water molecule, loss of ethanol, then forms isoxazole is the product. And here phenyl. Third one is from aryl alkyl ketone. Third one is aryl alkyl ketone. From aryl alkyl ketone, when this aryl alkyl ketone reacting with hydroxylamine, then this is the hydroxylamine. When loss of water molecule, oximes of carbonyl compounds of the formation takes place. CH3, here aryl. Now it is when reacting with base. I am taking strong base like alkyl lithiums. Strong base alkyl lithium. This base subtract this alpha position of ketone. These methyls are active methylates. These are active methyls. Methyl hydrogen. These are active hydrogens. Alpha position of carbonyl compounds. And this base subtract the proton from oxygen of oximes of carbonyl compounds. Then negative charge on carbon and negative charge on oxygen also develops. Here aryl. Okay, when this compound reacting with another mole of carbonyl compounds. That is I'm taking here ester. When it is involves loss of ethoxy is elimination takes place. Then double bond OR, here NO minus, here aryl group. Now it is involves here negative charge attack at the carbonyl carbon, and this pi bond shifting to oxygen side, then forms a 5-membered ring. Here aryl, here R, here O minus. Now it is reacting with concentrated H2SO4. When reacting with concentrated H2SO4, then reacting with concentrated H2SO4, the hydrogen shifting to here, then then forms OH. Here R and N aryl and hydrogen. It is involves loss of water molecule. Then forms isoxazole is the product. So this is another method. So this of isoxazole containing carbonyl compounds having alpha hydrogens. Carbonyl compounds with alpha hydrogens. This is one method. And another method is from nitrile oxides. When here another starting material is triple bond alkene. When reacting with alkene is reacting with nitrile oxide. Here hydrogen. undergo 1,3 dipolar addition reaction. 1,3 dipolar addition reaction. 1,3 dipolar addition reaction involves, need to like this, 1,3 dipolar addition reaction. Then the product is here R, here C, and O, N, H. This is isoxazole. This is one method to synthesis of isoxazole from nitrile oxide. Next one is reactivity. Next one is reactivity. So isoxazole is a weak base. It is undergo electrophilic reactions more readily than pyridine, but less readily than furan. So electrophilic reactions are more reactive. Electrophilic addition reactions are more feasible on isoxazole ring. Okay. First, we are doing electrophilic substitution reactions. So because of electron withdrawing nature of pyridine nitrogen, isoxazole undergo few electrophilic substitution reactions. Electrophilic substitution takes place in C4 position. Electrophilic substitution reaction takes place at C4 position. Electrophilic substitution reaction takes place at C4 position. Okay. We're discussing electrophilic substitution reactions. Here I'm taken so one by one electrophilic substitution reactions. This is isoxazole. When this isoxazole undergo reacting with nitration H2SO4 and HNO3. H2SO4 and HNO3. Nitration takes place at C4 position. Okay. This is C4 position. So 1, 2, 3, 4. So C4 position, nitration takes place at C4 position. Next one is sulfonylation, reacting with H2SO4 when bromination with NBS bromination, chlorination, so these are the best example for electrophilic substitution reactions. Reactions with nucleophilic reagents. Due to the presence of pyridine nitrogen, the halogen in 5th position undergo nucleophilic displacement more readily. That means if it is in isoxazole, if halogen at 5th position, halogen at C5 position, readily undergo nucleophilic displacement reactions. So when I'm reacting with ammonia, loss of HX, so nucleophilic substitution takes place at 5th position, NH2. So this is a way to write the nucleophilic displacement reactions. And strong base open the ring system. So when we use a strong base, open the isoxazole ring system, that with isoxazole unsubstituted in 3rd position and end position, and beat with the product of beta keto nitriles are the products. Yep. If unsubstituted isoxazole, when we take unsubstituted isoxazole, unsubstitution isoxazole, that means without no substitution on C3 carbon. 1, 2, 3. It's third carbon. There is no substitution. In third carbon, there is no substitution. There is no substitution when reacting strong base. I'm taken N when reacting strong base N-butyl lithium. That is N-alkyl lithium. This is a strong base. Base abstract the proton from here. Base abstract the proton from here. They produce negative charge at third position. This negative charge open the ring system. This negative charge helps to open the ring system. So this is undergo tautomerism, then forms alpha beta. Beta keto nitriles are the products. Beta keto nitriles are the products. This is the one of the method of when reacting with the isoxazole reacting strong base. So opening of the ring system takes place. Okay, if it is this is the example for there is no substitution at third position. If there is no substitution at fifth position, if substitution present at third position and there is no substitution at fifth position, if it is there is no substitution at fifth position, C5 position, when reacting with base stream, when reacting with strong base, base abstract the proton from, and so we are getting a negative charge here. This negative charge help to open the ring system. This negative charge help to open the ring system. Then the product start. The product is CCO minus plus cyanide is the product. This is the best method, is the opening of ring system when there is no substitution at the fifth position. When next one is next one is thermal rearrangement. Very, very important. Thermal rearrangement. Very, very important. Thermal rearrangement. Thermal rearrangement. When this is isoxazole is converted to oxazole. R dash, R double dash. This is isoxazole. When isoxazole upon heating, then converted into oxazole. Isoxazole is converted to oxazole. Isoxazole is converted into oxazole. So mechanism for this isoxazole is converted into oxazole is when this compound undergo here the bond cleavage, homolexical cleavage between carbon and oxygen nitrogen single bond. There is a homolexical cleavage between oxygen and nitrogen containing single bond. Then two radicals are the formation takes place. Two radicals are formation takes place. When two radicals formation takes place, nitrogen radical, then R dash, R double dash. Okay. When this compound, here again this is homolexical cleavage, undergo this pi bond undergo homolexical cleavage, then R double dash, single dash, and here radical, nitrogen radical R. When this compound, here there is a bond formation between these two radicals. The bond formation between these two radicals, then the product is R double dash, R single dash, R M double bond, and here. When it is undergo here. Now homolexical cleavage between these two single bonds. Double dash, single dash, radical, and N radical. So now this bond undergo ring flipping. Now here ring flipping takes place. Ring flipping takes place. Ring flipping takes place. Then O radical, N radical, R dash, R double dash, and the bond formation between these two radicals R single dash or double dash. This is a method to conversion of isoxazole to oxazole. So this is a thermal rearrangement. Okay. Next we are discussing photochemical rearrangement. Next we are discussing photochemical rearrangement. Next we are discussing photochemical rearrangement. So in this photochemical rearrangement, same isoxazole is converted into oxazole. Isoxazole is converted into oxazole. Here I am taking R. Here I am taking here. When this compound under sunlight, under sunlight. So this bond is shifting here under photochemical condition. So bonds undergo rearrangement. Then ketone N R. So this is and this is pi bond. When this compound undergo involves in the bond formation between here. So this is the method to and shifting here, and this is the attached here. Then the product is N oxygen, where R. So this is the isoxazole. Isoxazole is converted to oxazole. Next one. So some of the biological important compounds are there. Sulfamethoxazole and antibacterial, and some of the compounds are present in your notes. That's a biological active compounds. Next, we are going to oxazoles. Next, we are going to oxazoles. This is the oxazole. So 1, 2, 3, 4, 5. This is oxazole. So oxazole. So now synthesis of oxazole is first one. Robinson Grabiel synthesis. Robinson Grabiel synthesis. So in this Robinson Grabiel synthesis, the starting material is N-acyl amino ketone. N-acyl amino ketone. Alpha acyl amino ketone is the starting material. This is alpha acyl amino acyl ketone is the starting material. When this compound reacting with acid medium, so when this reacting with acid medium, undergo keto-enol tautomerism, the carbonyl is converted into keto and here N, and this two carbonyls are converted into alcohols. And these alcohols involves loss of water molecule, then forms oxazole is the product. Next, from isocyanates. From isocyanates, in this compound, benzyl nitrile. This is a phenyl. benzyl nitrile, benzyl isonitrile, benzyl isonitrile reacting with base, base subtract the proton from here, base subtract the proton from here. Then when this compound reacting with acid chlorides, reacting with acid chlorides, so this negative charge benzyl equation replace the acid chloride, chlorine from acyl chloride, then the phenyl C double bond O, methyl N positive touch, N positive charge, triple bond C negative charge. It is involves like undergo addition cycloaddition reaction, then forms a 5-membered ring, here phenyl, here methyl, here positive charge in double bond, and here that carbon is negative charge. It is here hydrogen is there. This hydrogen donate a pair of electrons towards a positive charge carbon, and this hydrogen shifting to negative charge the carbon. The product is O N double bond phenyl methyl. So this is the method to synthesis of oxazole from isocyanates and acyl chlorides. Next one is alpha haloketones and formamide. Alpha haloketones and formamide. From that is alpha haloketones and formamides. This is formamide. And this formamide reacting with alpha haloketones. So alpha haloketones, this alpha haloketones. So when it is involves, so by so lone pair of nitrogen undergo resonance and negative charge on oxygen. This negative charge involves displays the halogen. Then R double bond C double bond O and R dash prime and O NH H. Now it is involves in keto tautomerism. Then there OH R double dash R single dash and NH RH. It involves loss of water molecule. Then forms oxazole is the product. So this is the third method to synthesis of oxazole from alpha haloketones and formamide. Next one is reactivity. So oxazoles are weak base. Electrophilic substitution reaction takes place on fifth position. Electrophilic substitution reaction takes place at 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 fifth position. 1, 2, 3, 4, 5. Electrophilic substitution reaction takes place 50 position. Fifth position. Electrophilic substitution reaction takes place fifth position. So when I'm taken, this is the when reacting with the NBS, reacting with NBS, reacting with NBS, bromination takes place at fifth position. Bromination takes place at fifth position. So, so next one is metallation. Next one is metallation. So metallation. Again, metallation of oxazole takes place at C2 position. Okay. Metallation of oxazole takes place at C2 position. At higher temperature, ring opening of litho derivative takes place. Okay. And I'm taken here, metallation takes place at second position. N-butyl lithium. Where negative charge and lithium positive charge. It involves in the ring opening. It is there is a ring opening takes place at high temperature. At high temperature, ring opening takes place. At high temperature, ring opening takes place like this. O minus lithium plus and N triple bond C. So when this compound reacting with Na2 charge, at low temperature, reacting with formamide, it displays the amide group, amine, secondary amine. Then formylation takes place at negative charge position. Formylation takes place negative charge position. Next one is pyrojoules. Next one is pyrojoules. So 1, 2, 3, 4, 5. Five murdering pyrojoule. Synthesis of pyrojoule. So next we are going to synthesis of this pyrojoule. Now we are going to synthesis of this pyrojoule. When 1,3-diketone compound. When 1,3-diketone compound reacting with hydrogen, reacting with hydrogen. So involves 2 moles of water molecule. Involves loss of 2 moles of water molecule like this. And N. Okay. Here, this is the compound involves undergo shifting of hydrogen from carbon to nitrogen takes place. No, this is the pyrojoule synthesis takes place. When we taken is the pyrojoule synthesis. Next, we are going to discuss from alpha beta acetylene compounds and hydrogen. Alpha beta acetylene compounds and hydrogen. Alpha beta acetylene and hydrogen. Alpha beta acetylene and hydrogen. So it is involves loss of water molecule. Involves loss of water molecule. Next, it is undergo Michael addition. Michael addition. So this is one of the method for pyrojoule. Next. So reactivity. When this nitrogen. So here free nitrogen in pyrojoule, nitrogen is there. This hydrogen present on nitrogen. Therefore, so substitution takes place on nitrogen. Nitrogen substitutions. So that's the compound and reaction with the nitrogens. When the substitution with nitrogen. So when pyrogen reacting with managed reaction, secondary amines, formaldehyde in acid medium, then aminomethylation takes place. This is a managed reaction and a nitrosylation which with HNO2, and nitroso derivative or formation takes place. When reacting with the diazomethane. So methylation takes place on nitrogen. So these are the best example for N substitution reactions. Next one is electrophilic substitution reactions. Electrophilic substitution reaction takes place at C4 position. Electrophilic substitution reaction takes place at C4 position on pyrazine, pyrazole. Electrophilic substitution reaction takes place on C4 position on pyrazole. 1, 2, 3, 4. This is the fourth position. Electrophilic substitution reaction takes place at fourth position, C4 position. When we are taken pyrazole, when this pyrazole reacting with HNO3 H2SO4, so nitration takes place at fourth position. And next, when we reacting with chlorine halogenation, chlorination or bromination, whatever may be chlorination or bromination. So this halogenation takes place at same electrophilic substitution reaction takes place at C4 position. So like this, some of the examples are there. So this type of electrophilic substitution reaction takes place at C4 position. Next. Nucleophilic substitution reactions. Nucleophilic takes place at C3 or C5 or C3 position in pyrazole. Metallation takes place in 5 substitution sodamide abstract, and the proton from third position ultimately leading to ring open takes place. Then pyrazole, N substituted pyrazole, when reacting with sodamide, N substituted pyrazole reacting with sodamide. So this sodamide abstract the proton from here at third position, develops a negative charge at here, or again this negative charge involves opening the ring or opening the ring. So this is the method. So negative charge is when we reacting proton, that negative charge on nitrogen substitute with hydrogen and C triple bond N. This is a method to synthesis of pyrazole. Next, imidazole. Next one is imidazole. Then this imidazole, this is the structure of imidazole. 1, 2, 3, 4, 5. This imidazole, 5 member 2 nitrogen containing product is imidazole. In this imidazole, first one is reacting with 1,3 dicarbonyl compounds, 1,2 diketones. Reacting with 1,2 diketones with 1,2 diketone and ammonia, 2 moles of ammonia and aldehyde. Aldehyde. So 1 part synthesis, it will be, we are getting The product is the product. We are obtaining this as the imidazole is the product. Next one is when reacting with alpha bromoketones, phenyl bromides, alpha bromoketone, alpha bromoketone, and amidine, loss of HBr and loss of water molecule. The product is the imidazole is the product. Next, we are going to synthesis from alpha amino. Next, we are reacting with the properties. Next, we go into properties. For the properties, this imidazole existing in two tautomerism forms. Imidazole existing in two tautomerism forms. When we are taken imidazole existing in two tautomeric forms, hydrogen is the compound. When we taken 1, 2, 3, 4, 4 substituted imidazole, 4 substituted tautomerism form. When this 4 substituted tautomerism form undergo tautomerism, then we are getting we are getting 5 substituted tautomeric form, because 1, 2, 3, 4, 5. We are getting 5 substituted tautomeric form. 4 substituted tautomeric form is converted into 5 tautomeric form. This is when monosubstituted tautomeric benzimidazole. Monosubstituted benzimidazole existing 2 tautomeric forms. That is 4 substituted tautomerism and 5 substituted tautomerism. And nucleophilic substitution and nitrogen containing free hydrogen. This free hydrogen undergo nucleophilic substitution reactions. Free nitrogen undergo nucleophilic substitution reaction. When I am taken here imidazole, benzimidazole, the nitrogen. This free nitrogen undergo reacting with SL halides. So loss of H6 like this. Electrophilic substitution reaction on nitrogen. Like this. And when this reacting with alkyl halides, loss of HX, same. And alkylation takes place. So these are the general methods, general properties of N-substituted alkyl halides. Next one is electrophilic substitution reactions. Electrophilic substitution reaction takes place at C4 or C5 position. Electrophilic substitution reaction takes place. Electrophilic substitution reaction takes place at C4 or C5 positions. C4 or C5 position in imidazole. 1, 2, 3, 4, 5. C4 or C5 position in imidazole, because these two positions are identical. Okay, we know already. So electrophilic substitution reaction takes place C4 or C5 position. When this imidazole reacting with similarly we know that reacting with nitration, HNO3 and H2SO4. Nitration takes place at C4 or C5, both positions are identical. When this compound, same, it is nitrate volume. When reacting with volume, sulfonylation takes place. Fourth position. Okay, nucleophilic displacement. A halogen at second position can undergo nucleophilic displacement. If halogen at second position, they undergo nucleophilic displacement. Halogen at second position undergo nucleophilic displacement. When I am taken secondary amine, so loss of HX, that halogen is replaced by nucleophile. So next one Yes, sorry for the disturbance. So continuation is isothiazoles. So synthesis of isothiazole from nitrile sulfides. From nitrile sulfides. When nitrile sulfides reacting with triple bond compounds undergo 1,3 dipole addition reactions. Undergo 1,3 dipole addition reactions. Then we are getting our isothiazole is the product. Isothiazole is the product. Next one is from estelenes. From estelene. First method. Second method from estelene. From already when isoxazole. From isoxazole.
నేహా నీకు అలర్జీస్ వచ్చినాయా?
From estelene. From isoxazole. In this isoxazole, when reacting with nickel hydrogen reduction, and the reduction of this bond between oxygen and nitrogen takes place. It is undergo when reacting with P2S5. P2S5, O oxygen is replaced by sulfur. It is undergo loss of H2. The loss of H2, then the product is this product. This then reactions. Electrophilic reaction takes place at reactivity. Electrophilic substitution reaction takes place at C4 position. Electrophilic substitution reactions takes place at C4 position. Okay. So when this here, the 1, 2, 3, 4 electrophilic substitution reaction at 3, 4 position in C4 position in isothiazoles. When it is reacting with nitration, NO3 H2SO4. Nitration takes place at C4 position. Sulfonylation reacting H2SO4, concentrated H2SO4, fuming H2SO4, then forms SO3H. So nucleophilic next reaction with nucleophilic reagent. Okay, when halogenate, when reaction with nucleophilic reagent, reaction with nucleophilic reagent, reaction with nucleophilic reagents. So halogen at C5 position, when this halogen is replaced by different nucleophiles. Here halogen at C5 position, when reacting with the amines, nucleophilic bases, NHR. This is the process. And when metallation, okay. So metallation takes place in C5 position of isoxazole. When C5 position is substituted, metallation takes place in C3 position, leading a ring fusion. Okay, C5 metallation takes place at C5 position. Okay, if C5 position is any substitution there in C5 position, and metallation takes place C3 position, and that C3 position undergo ring opening. When this compound react with alkyl lithium, so metallation takes place at C5 position. Here C5 position is free. When if it is C5 position is blocked with any group, metallation takes place at C3 position. Metallation takes place at C3 position. The C3 position involves ring fusion. Next, thiazoles. This is isothiozoles. Next, we are going to thiazoles. Thiazoles. This is a thiazole. The structure. This is a structure of thiazole. When thiazole, then general method for synthesis of thiazole from alpha halocarbonyl compounds. Synthesis from alpha halocarbonyl compounds. From alpha halocarbonyl compounds. When this alpha halocarbonyl compounds reacting with thioamide. When reacting with thioamide, one pair of electrons on nitrogen involves like this resonance, and here displays the halogen function group. Then NH. So here now it is undergo ketone tautomerism. OH. Yes, NH double bond R. It is involves loss of water molecule. Simply, it is involves loss of water molecule. Then forms thiazoles are the product. Okay. Next one is from Grabiel synthesis. Second one is Nemoid reaction. All Nemoid reactions are important. Remember that all Nemoid reactions in the synthesis of heterocyclic compounds, all the Nemoid reactions are very, very important. Grabiel synthesis. Grabiel synthesis. This is an alpha acyl amino ketone. Alpha acyl amino ketone. Alpha acyl amino ketone. alpha acyl amino ketone. When reacting with P2S5, this carbonyl undergo oxygen replaced by thio group and HOR. It is undergo loss of water molecule, then forms our thiazole is the product. The thiazole is the product. Next one, reactions. So electrophilic next reactivity. Electrophilic substitution reaction takes place at C5 position. Electrophilic substitution reaction takes place at C5 position and takes place at C5 position. Electrophilic substitution reaction takes place at C5 position. Bromination. Yeah, bromine. C5 position. 1, 2, 3, 4, 5. C5 position. And nitration. Nitration H2SO4 and HNO3. Nitration. Next, sulfonylation, concentrated or fuming H2SO4. Sulfonylation takes place at C5 positions. These are the general methods. When nucleophilic displacement reactions. Nucleophilic displacement reactions. Displacement reactions. So if halogen at C2 position, that halogen is replaced by nucleophile. The halogen, it is reacting with the thiophenol. This is thiophenol. This is a product. Like this, nucleophilic displacement takes place. And it's photochemical rearrangements, important. Rearrangement. Photochemical reaction or photochemical rearrangement when 2-methyl thiazoles, 2-methyl thiazoles in presence of sunlight, where the bond is shifting takes place. The bonds are shifting takes place where hydrogen and N methyl, and it is undergo shifting of bonds. Sulfur, shifting of bonds. This is the product formation takes place. So this is the today topic to synthesis of submembered heterocyclic compound. Next we are discussing synthesis of next class. We are discussing synthesis of 5-membered ring heterocyclic with more than 2 heteroatoms. Okay, thank you.